Hello everyone, I am Dr. Serajul Faizi, working as an assistant professor, Department of Chemistry, Langat Singh College, Muzaffarpur. Today in this video, I am going to talk about stereochemistry. So let us start learning of stereochemistry with introductions. The two major classes of isomers are constitutional isomers and stereoisomers. What does it mean? What is constitutional or structural isomers? You know, constitutional and structural isomers have different IUPAC names, the same or different functional groups, different physical properties, and different chemical properties. What is stereoisomers? Compounds with the same connectivity, different arrangement in space, they have identical IUPAC names except for a prefix like cis or trans. They always have the same functional groups. My friend, look at these two examples. Here 2-methyl pentane and 3-methyl pentane have different arrangement in different positions. So same molecular formula with different names. Now another example you can see here, same molecular formula, same name except for the prefix like cis and trans. So what is the configuration? The arrangement in a space of 4 different groups about a chiral center. Stereoisomers differ in configurations. Now, stereochemistry is a study of the three-dimensional structure of molecules. This is the main concept here. Now, look at these two examples. Importance of stereochemistry. Stereochemistry plays an important role in determining the properties and reaction of organic compounds. Look at here, caraway seed and spearmint. Both have the same structure, but if you look properly, then you will see the differences between these two structures. The properties of many drugs depends on their stereochemistry. Look at here. This example is ketamine and R-ketamine. S-ketamine used as anesthetic and R-ketamine used as hallucinogen. Now, enzymes are capable of distinguish between stereoisomers. Look at this example. A particular enzyme fit with particular compounds and particular stereochemistry. So this compound will fit with this, but this compound is not fitting with this enzyme. So that's why we are saying enzyme is a specific in nature. Now, my friend, chirality. What is chirality? Although everything has a mirror image may not be superimposable. Some molecules are like hands, left and right hands, are mirror image, but they are not identical or superimposable. Look at here. Left hand, your left hand, and your right hand. This is non-superimposable. So, another example you can see here. Other molecules are like socks. Two socks from a pair are mirror image that are superimposable. A sock and its mirror image are identical. A molecule or object that is superimposable on its mirror image is said to be achiral. So, socks are achiral. They are mirror image that are superimposable. My friend, A molecule or object that is not superimposable on its mirror image is said to be chiral. Now, look at here. We can now consider several molecules to determine whether or not they are chiral. Look at the water molecules. The bonds and atoms align. H2O is achiral. Very important information. Now another example. Chlorobromomethane. Mirror image you can see. Rotate the molecules to align bonds. So this is achiral. So in general, a molecules with no stereogenic center will not be chiral. With one stereogenic center, a molecules will always be chiral. With two or more stereogenic center, a molecules may or may not be chiral. So achiral molecules usually contains a plane of symmetry, but chiral molecules do not. So my friends, stereogenic center, asymmetric carbon, chiral center, and chiral carbon. These are very important terms to understand the stereochemistry. So the most common feature that leads to chirality in carbon compound is the presence of an asymmetric or chiral carbon atom. A point in a molecules where four different groups or atom are attached to carbon is called a chiral carbon or chiral center. There are two non-superimposable ways that four different groups or atoms can be attached to one carbon atom. My friend, if two groups are the same, then there is only one way. This is also very important point. A chiral molecules usually has at least one chiral center. This is one conditions, not all conditions. So always omit from consideration all carbon atom that cannot be tetrahedral stereogenic center, and these include CH2 and CH3 group. Any sp or sp2 hybridized carbon, you look at here, stereogenic center at carbon, stereogenic center 3-bromohexane. This carbon is bonded to hydrogen, bromine, ethyl, and normal propyl, two different alkyl groups. So in general, no asymmetric carbon, usually a chiral. One asymmetric carbon, always chiral. Two asymmetric carbon may or may not be chiral. For example, you can look at here. Identify all asymmetric carbon present in the following compounds. This is your homework. So my friends, I hope this video will be helpful to you. If you like this video, then I will upload more such type of video, and this video actually I am making for assignment because we are developing e-content and we are doing a course, short-term course, development of e-contents. So I hope this video will be helpful to you. Thank you for watching.